In this sample problem, we'll determine the Laplace domain transfer function of the circuit below. Part A without buffer as it is, and part B with the same element, two C's and two R's, two capacitors and two resistors, the same elements, but with a buffer in between by cascading the two filters. First, we redraw in terms of Laplace domain. So it's the same circuit as above. Now we'll change this will be V I of S, and then now this will be V out of S. C1 will be 1 over SC. C2 will be 1 over S. So I'm going to do this one here as well. Okay. And we are looking for a transfer function. So what do we say about transfer function? We are looking for V out over V in. So we always draw a box. Let's say the transfer function is h of s, and that's V in, and that's V out. So, or you can write down V in times h of s equal V out. Therefore, h of s. So our s sometimes looks like a 5, so that's why I put a little bit of a note there, so it's completely s rather than 5. V out, V in. Okay, so what do we do first? Now you label everything. So this is V C1 plus minus. This is V R1. This is V C2. This would be plus minus V R2. So along the same line, you will have your current. Let's label each one of it. We'll just name and number it. Let's say this is I1, or you can say VC1. And then let's say this one is I2. That is I3. And then make sure you have, that will be a node. You can label this one I4 as well, might as well for the completeness. Let's write down all the equations. VC1 is I1 times the impedance 1 over SC1. V R1 is I2 times R2. V equal IR. VR2 equal I3. Oh, that's supposed to be R1. R2. And C2 is I4 times 1 over SC2. But I want you to note it. So these are all the V's. What I want you to notice is those currents. And let's have a look at it. KCL at node A. We'll assume everything that's going into node is positive. So sum around that node should be 0. So let's see, I1 goes in, that's a plus. I2 is out of the node. I3 is out of the node, equal 0. And another thing, let's do KCL at node B. So that this will be node B. Even though it's obvious, we'll do step by step. Current going into the node B is plus I3. Current going out of the node B minus I4 equal 0. So you can say I3 is I4. So you can replace wherever you see I4 with the I3. So you can do that right here. So that will be I3 1 over SC2. And also you know that from here, I3 is I1 minus I2. KVL around the loop. So R1, R2, and that was 1 over SC2. That was node A, node B, VR1, that is minus plus, because it's opposite direction, and VR2 plus VC2 equal 0. So we can kind of write it in this manner. VR2 VR1 VR2 plus VC2. So I'll call it equation 1 since I'm going to use it. So you place exactly what VR1 is. So from equation 1, I'm going to rewrite it here. That was I2 R1 equal VR2, which was I3 R2 plus BC2, which is from there I3 1 over SC2. So we'll leave this one and then we'll put it together in terms of finding out what I2 is. That would be I3 bracket R2 plus 1 over SC2 divided by R1. Or you can kind of do this way, divided by R1. The same thing. And let's simplify it a little bit. That will be I3 SC2 SC2 R2 plus 1 . And then we can do a little bit, another one. So KVL around the whole circuit. How do we do? We had a V in. Now we had that. And then we had 1. I can kind of redraw just to so we have a C1, we had a C2, we had R1, this is R2. So trying to find out what V in is. So in this case, we should have put capital V I plus minus. And then literally your V out, where it used to be here, plus minus V out. But we just want to find out VI in terms of the rest of it. So KVL VI, so it's minus plus this was I1 and this was I2 and this was I3, and we know that I4 was the same across the C2, right? So instead of writing down as a C2 here, I'll be write down ZC1 ZC2. So ZC1 indicating it's 1 over SC1 ZC2 SC2 for the completeness. So we need voltage across C1 and then you add voltage across R1, that's pretty much same as R2 plus voltage across C2, and then that whole loop should be 0. So that's a KVL around this whole thing. And let's find out. So you can rewrite it. VI equal VC1 plus R2 plus VC2. And then you just plug in what was VC1. VC1 was from earlier. VC1 was 1 over SC1. I times P equal IR or IZ, and then Z happened to be 1 over SC1 plus R2 is the same. Oh, you have to write down P1. R2 is I3 R2 because right there it's an I3 that's going through the R2 plus what goes through the IC3? I mean that's I3, and then the impedance of capacitor 2 is this. So from here, that's why I like to use KVL as it is instead of directly saying VI equal the rest. You do write down the whole thing equal 0, and then you give some room between, and then write down exactly what those are underneath. And now you simplify by putting it together. We can, oh, so that would be I1, just I1. And we can start writing as I1 1 over SC1 equal, now we can just kind of move it around, VI minus I3 combining R2 plus 1 over SC2. All I did was get these S3 out, and then you have a R2 and this one here, and it used to be left side and equal right side. We just kind of moved it around, so on your right side I1 over SC1 you put in the left, and then B1 put into the right, and the rest goes along with it. It's just algebraic manipulation. We need to expand a little, so it's VI minus I3. We're trying to kind of have a form SC2 SC2R2 plus 1. Later we'll put it back to like R2C2RC, but for now I'm just kind of following exactly where we were. This one, okay. And I'll still write down what was on the left. Now we can write it 1 in terms of the rest is VI times SC1 minus I3. You still have to have SC1 times the whole thing is. Now I'm going to switch to R2C2 plus 1 over SC2. So just like a SC2 there, and SC1, we just multiplied the both sides with the SC1. So keep going from there, remember from earlier KCL, we had I3 equal I1 minus I2. So if you go back all the way, it is right here. We can start writing. So I3 is I1, which is this whole thing up here. So I'm going to write down I1 first, literally rewriting V I SC1 minus I3 SC1 times SR 2C2 plus 1 over SC2. So the advantage of not skipping lines are you can trace it back. Minus, what was I2? I2 we calculated somewhere. Right here we have I2. It was I3 R2 C2 plus 1. So that was I3 R2 C2 plus 1 over SC2. It was times 1 over R1. So double check. Yep, that. You see something interesting. Now everything is in terms of I3, I3, I3. These are common, so we'll take it out. So we'll rewrite I3 equal, we'll still leave not small letter, capital letter I as C1 minus I3, and then we'll get these big bracket SR2C2 plus 1 over SC2, close a bracket, open another bracket, SC1 plus 1 over R1. So that was from the above, and you had this one, SC1, and this one here. So there's still a little more work. We're trying to find out, and what we're trying to do eventually is trying to find everything in terms of I3. Okay. So let's move things around again. Let's move that one here and this one over there. we rewrite VI times, this is not VI of, times SC1 equal I3 plus I3 of this whole thing. And let's do a quick simplification directly from here. So it will be R1 SC1 R1 plus 1. Okay. And then I will do another iteration. It's S3 1 plus the rest. So SR2C2 plus 1 over SC2. But don't forget that is still having those bracket times, and the big bracket are 1. But on the top we'll rewrite it SR1C1 plus 1. That is 1. I'll make sure that's C1. It looks kind of getting big, but it will still be manageable, trust me on it. We want to have no upstairs and downstairs and all the bunkers all over, bunker beds all over the place. So I3. Now we want to combine everything. Instead of making one more step, I'm going to go in one step. So I want everything underneath to be SR1C2 because of that one here. You have one up there, so SR1C2 plus, now we only take care of all that's on the numerator. And I'll still write it so you can expand it later. SR2C2 plus 1 times SR1C1 plus 1. So this portion is here. This portion is here. Now what we do, we just need to, I'll still write down V I S C1. Now we want to write everything in terms of I3. So I3 equal V input SC1. Now we multiply both sides by SR1C2 over S R2 C2 plus 1 SR1C1 plus 1. That looks like a G, so I'm gonna rewrite C1 plus SR1C2 whole thing bracket. So literally I3 is this. We want to solve, we were asked to solve V out, V in. And what was V out, V in? So first you have to find out what was V out. V out was a VC2 across the capacitor 2, and that was I3 ZC2, which is I3 1 over SC2. So if you're not sure, we can always go back to the drawing. So over here and also over here, VM is literally VC2. And then V in, we'll just write it as a V in. Look at this. I3 happen to be, so we write down V out which is this, and we rewrite the whole V I1, so was I1 SC1 over SC2. So this SC2 is this SC2, and this SC1, it's coming from this SC1. And I'm gonna write the rest, R1, C2. We can expand it, but we'll just leave it for now. S like R1, C1 plus 1, S R2, C2 plus 1, plus SR1, C2. I just like to order it as RC and then 1, then 2. And then let's look at this. This S cancels out. This C2 cancels out this C2. So V out over V in, since this one goes over here, equal, now we gather everything. So it's S R1 C1 over SR1 C1 plus 1 times SR2 C2 plus 1 plus SR1 C2. So this is your final answer. And that what really helps me grading is if you clearly write down in sequence like a RC and the ones first, and then one here, two, two, one, two, and if write in sequence, it's so much easier to grade. Now this is the second part of the problem, part B. So this was your original drawing. Now I'm going to kind of move it out of the way. And then I'll have two separate. So I just kind of moved these around so that it's now two separate circuits. But that's cascaded. So you have new terminals. I'll call in two circuits. So this will be V out 2. This will be V out 1. Plus, minus. Between the circuit on the left and circuit on the right, that's CR and then RC circuit. And then let's see what we can do with it. So I'm going to, instead of redrawing, well, maybe we should redraw it into Laplace domain. So that will be ZC, and then this will be just R1, C1, and like this. That will be capital V out 1. That will be capital V in, plus, minus, plus, minus. Let's work with the first portion. First portion, it's simple voltage divider. V out 1 is R1 over R1 plus ZC1 times VI. And remember ZC1 is pretty much R1 plus 1 over SC1 VI. So VO1 over VI equal, we didn't want to have a bunker beds on the denominator nor in the numerator, so we multiply both numerator and denominator by SC1, so that will be SC1 R1. We just multiply it. So in here you have R1, you multiply it by SC1. I'm just showing, and then 1 over SC1 times 1 over SC1 is 1. So if you rewrite it more neatly, V out 1 over V in would be SR1C1 over SR1C1 plus 1. Nice. And then what about the second portion? Second portion, we have R2, and we have, let's put it in, we have R2, and we have ZC2, and that's happened to be our V out 2, and our V in, let's say this is V in input 2, where V output of 1 is V input of 2. There will be still capital letters. I will put capital letters. VO2 is, again, same thing, ZC2 over ZC2 voltage division R2 V in 2. And then you write it. It would be 1 over SC2, 1 over, oh, that's not your problem, so I'm gonna 1 over SC2, 1 over SC2 plus R2 V in 2. So you will end up with VO2 over V in 2 is, you multiply both sides by SC2, so it will be 1 over 1 plus R2 SC2. You multiplied both sides with the SC2, well, that's what you just did. And then you rewrite it nice and neat. It'll be 1 over S R2 C2 plus 1. That will be VO2 over V2. So that was the second circuit. If you want me to elaborate, that will be that you were multiplying both sides SC2, this whole thing SC2. So when you cascade it, system with buffer means you have one transfer function, another transfer function, so that will be V1 out over V in, and this will be VO2, so let's say VO1 output 2 over V, that was I2. So first one was SC1R1 over S, oh, I'm gonna rewrite it. Already did R1C1 and SR1C1 plus 1. And when two transfer functions are in series, you multiply. The second one was 1 over SR2C2 plus 1. So overall system is of a V out, V in. So where V out is literally V output 2 of the second circuit, but in from the original circuit drawing, you can rewrite it whole thing as SR1C1 over SR1C1 plus 1. Please put the bracket. SR2C2 plus 1. And this is your final answer for cascaded case. Do you see the difference between part B when it's cascaded and when it was not cascaded. So I'm going to copy for the comparison purpose. And I'll put it here. So this one was from part A without buffer. So without buffer, you see there's this term. It's almost the same, but different.